Hello, we're looking at differentiating between the character code representation of a decimal digit and its pure binary representation. So I've got two digits for you, that being 23. So this is meant to represent an integer. And if we were to convert this into a form that a computer can understand, binary, this would be the binary representation. This, however, is a string made up of two characters, the 2 and the 3. And so each of those characters has their own character code representation. Now if we go first for the string, if we look at this, these are the character codes using ASCII for the characters 2 and 3. So if we break this down into, or rather convert this into a hexadecimal, we get 32 in hex, and for this one we get 33 in hex. If we look at the table, this is the ASCII, extended ASCII table, and we actually look up 32 and 33, we get the character code there, and there is the actual character. So we can retrieve that character and pull it out of the table using these character code representations. If, however, we look at the integer, the decimal value, 23, well, this is represented using place values instead. So the lookup or the generation or the representation of these values are different. Another way we can look at this is to actually look at it in Python. So if I look at, firstly, the string or character representation of this, we get string. If I look at the pure binary representation, we get an integer. In fact, if we were to do some arithmetic on this, so if I was to times it by 4, I'd get that, whereas if I times it by 4 using the actual integer representation, we get a proper value. Now we can actually look up using ORD the ASCII character value for this. Now that's in decimals, so if we convert that to hex, we get back our 32 that we found in the ASCII table. Thanks for watching.